In this video, I am going to explain some very important points. And the first point is the position of hydrogen in periodic table, or simply we say position of hydrogen. Actually, hydrogen has anomalous character, or it has anomalous. So we start with it has anomalous position in the periodic table. So we see anomalous, but what is the meaning of anomalous? Anomalous means something which is peculiar or something unique. So anomalous means unique or peculiar. So what is the unique thing? What is the peculiarity or what is the speciality? So for this we have to go through the electronic configuration. So hydrogen, one atomic number 1, configuration is 1s1. So its valency is equal to +1, its oxidation number is equal to +1. So now see what is important. Just I am writing alkali metal like sodium. Atomic number 11, 1s2, 2s2, 2b6 and 3s1. See the point. That what we say about alkali metals, they have valence cell configuration of ns1. Similarly here it is what? It is ns1. So it resembles. The first is it resembles with alkali metal. So this is the first point. Now I am writing about the halogens. Halogen family. Now halogen family, like take the case of fluorine, 1s2, 2s2 and here 2p5. The valence cell, it has valency of -1. So how it resembles with alkali, this halogens of alkali metal. So see, its resemblance is in the context. The fluorine can gain, if I write here, so fluorine plus an electron, there is formation of fluoride ion and it becomes 10. So here it has valency. Here it has valency of what? Now it gains one electron and so there is formation of fluoride ion. So similarly, if I write here hydrogen, so hydrogen will gain an electron and there is formation of this ion, H minus. So cationic hydrogen and anionic hydrogen. So here it is there is formation of H1. So as a result we say that hydrogen has anomalous character or anomalous position in the periodic table. Now coming to water, water is universal solvent. It is universal solvent because it can dissolve ionic as well as covalent compounds. It has abnormal properties. It is a colorless. Odorless means it has not any smell. Odorless, tasteless liquid. Pure water is having no taste, and it is volatile also, and it has anomalous character. It has anomalous character, and it is not found in any other compound related to hydrogen, water. So like in solid form it flows over water. It floats over water. And this floating is due to formation of extensive hydrogen bonding. See here, there is the one molecule, this is the hydrogen bonding, and there is the point here, just there is hydrogen bonding. Similarly, there is the, so in this manner, there is the air gas. So water has extensive hydrogen bonding, and in solid form it is perfect. So ice has perfect hydrogen bonding between molecules, and air is captured. Air is captured, and so when air is captured, what happens? Ice floats over the surface of water, and so it has very strong tendency to absorb the heat also. Now, see the structure of water molecule. So, water molecule has bent structure like this. Here there is one lone pair. This is the lone pair. This has bent or angular structure, and here this angle is 104 degree and 5 minutes. So this is there. Angular, it is having polar nature also. It is having the polar nature because oxygen has the negative charge, hydrogen has the positive charge. So two poles are present, and so water has polar nature. So this polar nature is very much important for water. Now I am coming to chemical properties of water after physical properties. So first is amphoteric character. And amphoteric character means acidic as well as basic. When acidic and basic both the characters are exhibited by a substance, it is called as amphoteric character. And see how? If I take 1 mole of water, this is 1 mole. Now here take other mole and see the reaction. H3O this L, you can write here. This is aqueous, and there is the formation of OH and aqueous. Now this is a strong acid. How do we manage? Strong acid. Similarly, this is what? This is a strong base. OH is a strong base. But why neutral? Why amphoteric? Because strong acid and strong base react together to form the neutral compound. And if I take here 1 mole as weak acid, and this is weak base. Hydrogen, combines with oxygen to form the water. It is hydride of oxygen. You know about hydride? So water is hydride of oxygen. So weak acid and weak base. Water is tasteless. So weak base forms a strong acid, and weak acid forms a strong base. And this is the concept of conjugate acid. This is the concept of conjugate acid base pairs. This is a very important point. Conjugate acid base pairs. Now, what is the meaning of conjugate acid base pairs? Water is weak acid. So, weak acid, any weak acid, always produces a strong base. How it produces strong base? By loss of H. It loses H to form the H3O. So that's why weak acid forms a strong base by loss of HN. Now here there is weak base. So weak base forms a strong acid how? By gain of H. So this is the meaning of conjugate acid base pairs, and this is called as self-ionization. This is called as self-ionization of water, or autoprotolysis. Autoprotolysis. Auto means automatic. Protolysis means breaking. So this is very important point about the amphoteric character of water. Now we will see the next property. Now water responds redox reactions also. Water undergoes oxidation as well as reduction also. So redox reactions are responded by water. See how? If you take any metal, like sodium, solid, in presence of water, liquid, there is formation of NaOH aqueous, plus there is formation of hydrogen gas. So what we can say? That sodium has undergone oxidation and water has, it has undergone reduction. So it is there about the redox reaction. So it can same with the calcium or potassium, any reactive metal, so it can there. Now other is, hydrolysis. Water also causes hydrolysis. It dissolves many substances and hydrolyzes them. Like if we take here SO3 plus H2O, then there is summation of H2SO4. Similarly, I write here NO2, H2O, there is summation of HNO3 aqueous. So this is about the hydrolysis. It hydrolyzes many substances to form the corresponding aqueous solutions. Now next is hydrate formation, means formation of salts, or we say compounds, salts or compounds in which few and a specific water molecules. Few means few number, few but specific water molecules are captured inside the molecules. You have seen water of crystallization in class 10th. So, water of crystallization is the number of water molecules which are responsible for the properties of, physical properties rather, of some compounds. You know about the potassium sulfate, you know about the copper sulfate, and so there are many compounds. So, first we take what you write, COSO4, 5H2O. So, actually it is like this, COSO4, H2O4, and there is 1. So this is the real scenario. This square bracket, it is called as coordination sphere. You will see in class 12. This is coordination sphere. So 4 water molecules are inside and 1 is present outside. So this is found in some specific compounds, and this happens in all the cases. And so this is about the chemical properties of water. Now coming to next, heavy water, D2O. It is called deuterium oxide. You must know heavy water. Heavy water is very important substance for the nuclear reactors because it acts as moderator. It acts as moderator in nuclear reactors, and it also as a chemical in many reactions. So it is slightly having more density, and it is prepared by the hydrolysis. It is prepared here. See preparation. It is prepared by the constant hydrolysis of water. Now, a special method for very long time period, very slow, and so then it is obtained in very small amount, then it is further refined by fraction distillation, and there are many complex processes. Now it is slightly thicker, and its reactions are very similar to the water. It reacts with some substances like, say, if you take this calcium carbide, and this is deuterium oxide or heavy water. So there is carbon deuteride, and this calcium oxydetride. This is calcium oxydetride. This is carbon deuteride. Similarly, if you take SO3, and so there is deuterium sulfate. Just like H2SO4. Why actin? This is because heavy water it has similar character with that of water, but it is not fit for consumption. It is very dense, and so it has not viability. It is dangerous for the consumption of any animal. So, and moreover, it is very expensive, very expensive, and so this is about the heavy water. Now we are in the last segment of this chapter, and here I am explaining about the usage of hydrogen and the hydrogen economy. So, usage of hydrogen in making different chemicals. Different chemicals are prepared by hydrogen. Different chemicals by chemical changes. See how? If I write here, this is ethene, and on passing hydrogen gas, in presence of nickel or platinum, absence of air, and there is formation of CH3, ethene. So this unsaturated is converted to saturated. Similarly, there is, in making vegetable ghee, then as hydrides, hydrides, particularly metallic hydrides, they are believed to be the future of energy in terms of renewable energy, or in terms of any energy which cannot be lost. Just reversible reactions, because metals can, metallic hydrides are interstitial hydrides, so hydrogen atoms are, placed in between the interstitial places, and so reversible reaction takes place. So hydrides, metallic hydrides. So then in fuel cells are a special type of battery door cells in which hydrogen and oxygen gas is passed, and there is the generation of current. So it is going to be, revolutionize the entire world. It is used nowadays in European countries, cars, buses, they are running by fuel cells, and in a space missions, all the spacecrafts, they have multiple system of power supply. They have solar panel, they have storage battery, but they have fuel cells also, because the stores require water for drinking and different purposes. So fuel cells are there. And so hydrogen economy is very much important, and this hydrogen is coming out to be as a boon for the coming generation. And so this is about the hydrogen.